Hello everyone, welcome to yet another video from me. So in this video, we're going to go through the Form 4 Chapter 3, Logical Reasoning. Right? So let's get into it. Right. So the Form 4 Chapter 3 is Logical Reasoning. So what is logical reasoning? Basically, in this chapter, it's going to be a lot about following the format of answering the questions. Okay, as long as you know how the structure works and also a basic understanding of how to decipher things logically, okay, then it shouldn't be much of an issue to you. So it's very hard for me to go through the basics of the whole chapter by itself. So what I'm going to do is I'm going to straight away look at the questions, and from the questions, I will try to explain to the best of my abilities. So let's see here. Question 1, determine whether each sentence below is a statement or not a statement. Okay, so how do we determine whether something is a sentence is a statement or not? So what makes it a statement and what makes it not a statement? Basically, a statement is something that you can say is either true or false. Okay, I can say it's definitely true, I can say it's definitely false. But if I cannot determine whether it's true or false, okay, if there's no way I can determine whether it's true or false, then it's not a statement. Okay, so how do we say that it works? Basically, if it has a truth value, then it's a statement. If it doesn't have a truth value, means it's not a statement. Okay, a truth value means you can certainly say it's true, you can certainly say it's false. So if we see each of the sentence here, a cuboid has 6 faces. A cuboid has 6 faces, I can say it's true, I can say it's false. In fact, in this statement, it's a true statement. Yeah, this is a true statement, but I don't actually need to say it's a true statement or not, so, or a false statement. So I just say it's a statement. Basically, because you can either say because it has a truth value or because it is true. Yeah. Or if it's false, then because it is false. So it's, if I can say with certainty it's true, say with certainty it's false, definitely it is a statement. This one, solve this equation. Solve this equation. See? Solve this equation. Keyword here, solve. Solve is in order. This is an order or a direction. They're asking you to do something. So when it's an order, a command telling you to do something, that cannot be a statement. Definitely is not a statement. Justification will be the truth value cannot be determined. So what does that mean? Basically, I cannot say it's true, I cannot say it's false. Okay, when someone gives you an order, when someone tells you, oh, pass me the bottle of water, you can't say it is false. It is true, doesn't make sense. So an order, a command, a request, all these cannot be statements because you can never say it's true, you can never say it's false. Okay. Like this, each cylinder has two curved surfaces. That's also a statement. Okay. Although it is a false statement. So because it is false, I can determine with certainty it is false. So it doesn't matter whether it's true or false, as long as it's either true or false, it's a statement. Okay. So don't forget to bring workbook tomorrow. Okay, that's a reminder. So it's like a command as well. So it's also not a statement. Basically, not a statement. It all uses this justification. Okay, so I don't think I need to repeat the justification here. As long as it's not a statement, it's always true value cannot be determined. This one, 3x plus 5 equals to 6. 3x plus 5 equals to 6. Can I say it's true? Can I say it's false? I cannot. Yeah. I don't know whether it's true or false because when I have an unknown like this, x can be anything. X can be any number. There are numbers that when I put in, it will be correct. Put in, it will be wrong. If I put like 1/3, then it's correct. Then it's true. But if I put anything other than 1/3, it's false. So I cannot actually determine whether it's true or false. So equations with a variable is not statement as well. Yeah. Okay. Like this formula is different because when I actually multiply, I can get in terms of A and B. So this one is a statement. Yeah. Because this, in fact, this is a true statement. Okay. Wow, this vowel is beautiful. That's an expression. Expression is also not a statement. I cannot say, hey, your expression wrong, huh? Vowel not beautiful, so you can't say that. Yeah. Doesn't actually make sense. It's just an expression of a person. So that cannot be determined whether it's true or false also. So it's also not a statement. Okay. The members of PDRM are government officials. That is statement. Okay. In fact, it is a true statement. And then 3 plus 5 more than 8. Although it's not, it should be equal instead of more than, but I can say it's false. So it's also a statement. Yeah. Because it is false. Yeah. Okay. So that's one of the most basic kind of 1 mark that you can get, determining whether the sentence is a statement or not a statement. Okay. So when it's a statement, we need to be able to say whether it's true or if it's false. That depends. That one, there's no really special trick to it. Yeah, you just have to logically think. Okay, you just have to logically think. Is there a case where it is wrong? Okay, and that case where it is wrong is what we call a counter example. Okay, an example of a case where it is false, where the statement given is false. That is what we call the counter example. So if we look at question 2 here, determine whether it's true or false. If it's false, give a counter example. True, there's no such thing as counter example because counter example is just an example to show that it is false. So if it's true, there is no examples to show. Okay, so if we see each of this, part A, x minus y squared equals to x squared minus 2xy plus y squared. If you're not sure, slowly expand it. Just take x minus y times x minus y, you will actually get this. So this is true. If you need to, just take x minus y times x minus y, then x times x squared, x times negative y minus xy, negative y times x minus xy, negative y times negative y is plus y squared. So x squared minus 2xy plus y squared, which you can see is correct. Yeah. Part B, all integers have positive values. That is false. Okay. Because negative, yeah, there can be negative integers also, and 0 is also an integer. So the example they give can be anything that is that shows it is not true lah. So I can take any negative whole number basically. So let's say I take negative 2. I can say negative 2 is an integer. That's the counter example. Okay, negative 2 is not positive, but it is an integer. A fraction is smaller than 1. A fraction is smaller than 1 is also false. Yeah. Because we have basically improper fractions where the number on top is bigger. So I can say any fraction basically, say maybe 503. 503 more than 1. All diagonals are perpendicular bisectors. All diagonals are perpendicular bisectors, also false. So you can, diagonals means from corner to corner. So for a square, diagonals are perpendicular bisectors. Yeah. But for most other shape, it's actually not. Okay, so you can say, let's say rhombus also, diagonals will be perpendicular bisector. So I can say maybe even rectangle, yeah, or perpendicular bisector means that means 90 degrees and cut in the middle. So for square, the diagonals here will be 90 degrees and cut at the center. For rhombus as well. This and this cut right in the middle at 90 degrees. But most other shapes wouldn't be. So basically you can just name any other shapes that say diagonals of rectangles of a rectangle. Are not perpendicular bisectors. Okay, just as simple as that. Then determine whether the following compound statements are true or false. Okay. Determine whether the following compound statements are true or false. So part A, 26 equals to 64 and 2 times 6 equals to 26. Yeah. So for n statements, one of it is false, then it's false. Sorry, got wrong. Yeah. For all statements, one of it is true, then the whole thing is true. Okay. Because for n statements, you need both to be true in order for the whole thing to be true. So as long as one of it is false, then I know the whole thing is false. Or statement, as long as one of it is true, then it's correct. Because it's either this or this. Yeah, it's either a boy or a girl. Definitely one of it is true. Yeah. Okay. But if I say, yeah, he's a boy and a girl, that doesn't make sense. Okay. So question 3 here, 26 equals to 64. That's obviously false. Okay, but it's an AND statement. So one of it is false, the whole thing is false. I don't even need to consider this. But even if I consider, it's actually both false. So part A definitely false. B, 9 to the power of -1 equals 1 over 9. This is correct. 9 is a factor of 72. Also correct. So since both true, then it's true. 25 is a subset of 236. This is false. There's no 5 here, so it's not a subset. Sorry. Union 57. My mistake. I didn't see the union. Union 57. So 2 and 5 we union first. Then, yeah, 2, 5 will be a subset of it. So this is true. Then n is a n of an empty set equals 0. Number of elements, that means number of elements is in an empty set is 0, which is also true. Definitely is true. 90 times 80% equals to 70. 90 times 80%. So 80% of 90, you can actually try to count. 80 over 100 times 90, it should be 72, not 70. So this is false. 8 times 8 times 8. Okay, 8 times 8 times 8 is 512. So this is also false. So yeah, whole thing is false. Okay, I think the question set is not very good. Most likely they will put like 1 true, 1 false here and there lah. But here it's like both true, both false. Yeah, question is not very good. Okay, we look at question 4 here. Write a true statement by using the quantifier all or some for the objects and characteristics given below. For a hexagon, characteristics has 6 vertices. So this one basically is all. There's no exception. All hexagon definitely will have 6 vertices, no matter how it looks. 1, 2, 3, 4, 5, 6 like that. Let's see. See, there's 1, 2, 3, 4, 5, 6 vertices. So this is all. For part A, all hexagons have 6 vertices. Part B, for circle has radius of 18 cm, that would only be some of them. Okay, that would be only some of them. Definitely it won't be all of it. Okay, because circle can have any radius. Yeah. So there's no way there's a fixed radius for circles. So some circles have radius of 18 cm. Okay. And part C, triangle has 3 axes of symmetry, also only some, only equilateral triangle. But we also have isosceles triangle. We also have scalene triangle, where all the sides are different. So this is also only some. Some triangles have 3 axes of symmetry. Yeah, that's question 4. Right. Then question 5. Determine the antecedents and consequence of the following statements. Okay, so what is antecedent? What is consequent? Basically, we have what we call the implications. What we call implications. So implications is basically your if-then statements. Yeah. If something, then something. So usually I use like P and Q lah. If P, then Q. P is always your antecedent. Q is always your consequent. Okay. Like if, okay, say if I work out every day, then I will get fit. Yeah, or I will build muscles. If I work out every day, then I will build muscles. So that is the antecedent and consequent. What I do first, what happens first, and then what will become the consequences of the action of that something happening. Yeah. Okay. If I go and shower now, then I will smell better after. So that's antecedent and consequent. What happens first is your antecedent. The consequence is what will happen due to that, due to the first thing happening. Okay. Yeah. So part A1 just determine antecedent and consequence. So actually quite straightforward. So A1 antecedent is P less than Q. And the consequent Q minus P more than 0. And for the second one, if the perimeter of a rectangle A is 2 bracket x plus y, then area of rectangle A is xy. So it means antecedent perimeter of rectangle A is 2 bracket x plus y, and the consequent area of rectangle A is xy. Okay, that's how it works. Part B, make an appropriate implication based on each of the following pairs of implications. So when we have 2 pairs of implications like this, we can combine them into one implication. Okay. When the pair of implications is switching between the antecedent and consequent, means it works both ways. Okay, it works both ways. So if x is an even number, x can be divided by 2. Means any number can be divided by 2 basically. So I can also put it the other way. If x can be divided by 2, then x is an even number. So that's when we can combine it into what we call the if and only if statements. So it will be P if and only if Q. Doesn't matter which one comes first, actually. Yeah. Because if it's if and only if means it works both ways. Yeah. So part B1, just combine this. If x is a multiple of 10, x is a multiple of 5. If x is a multiple of 5, then x is a multiple of 10. Means x is a multiple of 10 if and only if x is a multiple of 5. Yeah. Okay. But just for information, the question is wrong. Yeah. X is a multiple of 5 doesn't mean it's a multiple of 10. 5 is a multiple of 5, but it's not a multiple of 10. 15 is a multiple of 5. It's not a multiple of 10. Just for information, this is actually wrong. Yeah. Whoever said this question said it wrongly. But the structure of the question is still correct. Yeah. It's just the statement that they use should be changed. Okay. Yeah. Then we look at the next one, B2. If 6 is a factor of 12, then 6 is a factor of 24. If 6 is a factor of 24, then 6 is a factor of 12. So also combine if and only if. 6 is a factor of 12 if and only if 6 is a factor of 24. Yeah. Okay, these are the two statements, two implications, two combined implications. So if we can combine them, naturally we can also separate them. So that is what is going on in the part C. So we need to separate it into two implications from the if and only if statement. Yeah. So C1, if 20% of 30 is 6, then 0.2 times 30 equals to 6. So I can put the other way as well. If 0.2 times 30 equals 6, then 20% of 30 is 6. Yeah. That's the two statements, two implications. C2, same thing. M is divisible by 20 if and only if M is divisible by 2 and 10, means if M is divisible by 20, then M is divisible by 2 and 10. Okay. The other one is the other way. If M is divisible by 2 and 10, then m is divisible by 20. That's how we separate the if and only if implications. So they can ask you in either form. Make sure you know how to separate and also how to combine. Okay. So question 6 here. Write the requested statement in brackets for each of the following and determine the truth value of the return statement. Justify your answer if it's false. So we need to know what is inverse, converse, contrapositive, and negation. Negation basically, if it starts off true, then it will become false by using not. Okay. Negation is basically where you not a statement, means turn it into the opposite of that. Means I can say a triangle has 3 sides. Okay. Negate that, a triangle does not have 3 sides. That's negation. Yeah. From a true statement becomes a false statement. Or it can be false, become true also. Okay, I can say a square has, say, 2 axes of symmetry. By right, it should be 4. So it's false. But if I negate it, then it will be a square does not have 2 axes of symmetry. 2 axes of symmetry, which is false, which is becoming true. That's how negation works. By using not. So it either change from true to false or false to true. Definitely you will change from the original statement. Okay. Then, if we start with the statement, okay, if P, then Q. What will happen when you converse it, inverse it, or contrapositive, of the statement? Yeah. So how would that work? So let's start with converse. Converse is basically when you switch the antecedent and consequent. So like the question before, the part C here, these two are the converse of each other. Yeah. So it means converse of the statement here would be if Q, then P. Yeah, switch antecedent and consequent. Inverse, if we refer back to the statement, if P then Q, what happens? It will negate the antecedent and the consequent. Means if not P, then not Q. Yeah. And contrapositive. Contrapositive will be combination of both converse and inverse. Means we switch antecedent and consequent from the statement and also negate them both. Means if not Q, then not P. Yeah. Okay. Now, statement and contrapositive will have the same truth value, while converse and inverse will have the same truth value. Means if the statement is true, contrapositive is true. If statement is false, contrapositive is false. If converse is true, inverse is true. If converse is false, inverse is false. But statement doesn't directly relate to your converse inverse. Yeah, it can be statement true, converse true. It can be statement true, converse false. It can be statement false, converse true. It can even be statement false, converse false. Yeah. Okay, so you have to think logically. But if I consider, say, contrapositive, I can see from the statement itself, or I can see from the contrapositive statement. So, yeah, from the original statement or contrapositive statement. Either way works. Now, let's look back here. Write the requested statement and then determine truth value. Yeah. Justify, basically, we can always use either a counter example or an explanation. Okay, but that's only if it's false. If it's true, no need any explanation. Yeah. So again, one good way to explain why something is false would be using counter examples. So part A, if alpha and beta are two complementary angles, then alpha plus beta equals to 90 degrees. Converse means switch and distant and consequent. Means if alpha plus beta equals 90 degrees, then alpha and beta are two complementary angles. Yeah. Okay, and then this is true. So true means no explanation is needed. Part B, if W more than 20, then W more than 30. Contrapositive means switch and distant consequent and negate also. Yeah. So how do we negate the, what do you call that? Inequality? Basically, negating inequality, it will be the opposite of it. So more than opposite will be not just less than, it's less equal. Yeah. If it starts less than, opposite will be more equal. If it starts with more or equals, then opposite will be less than. Okay. So if switch and negate means W less or equals 30, then W less or equals 20. Yeah. This would be false. Yeah, less or equals 30 doesn't mean less or equals 20. So we can give any counter example. I can say, let's say 24. 24 less than 30, but 24 is more than 20. Yeah, instead of less than. Okay, that's part B. Part C, if P more than 0, then P square more than 0. Inverse of that. Inverse means negate both antecedent and consequent. So if P less or equals 0, then P square less or equals 0. This is also false. Okay. So P less or equals 0, I can take, say, -2. -2 is less or equal, yeah, less or equals 0. In fact, it's less than 0. But -2 square is 4, which is more than 0 instead of less or equals. Okay, or you can use any other number, so -3, -4, -5, -1, doesn't matter. But D, sum of exterior angle of a polygon is 360 degrees. Negate it. So basically, I want to say that it is not. So you can say the sum of exterior angles of a polygon is not 360 degrees. Okay, so this I can say that it is, after negated, it is false. Because it will always be 360 degrees. Sum of exterior angle of polygon is always 360 degrees, no matter what polygon. Okay, that's question 6. Then question 7, we have arguments. Okay, arguments. So arguments always, we split, sorry, the special format of your arguments always, we have premise 1, premise 2, conclusion. Premise 1 is always a more general statement. Okay, means it's not specified to one specific object. Yeah, I can say all even numbers. Okay. Or I can say all dogs. Yeah. So maybe I say all dogs have 4 legs. That's my general statement. So premise 2 will be specific subject. So instead of saying all dogs, now I specify my pet. Yeah, my pet is a dog. So it's shrink down, this specific one is a dog. Then my conclusion will be my pet has 4 legs. Like that. Yeah. So that's how premise 1, premise 2 conclusion works. So the first form is using all statements, all something are something. This specific subject is that something, so it will fulfill that condition. Second form is if then statements. If P then Q, then subject is P, subject is Q. The third form is using the contrapositive. Okay, argument form 3 is using the contrapositive. Yeah. So if my premise 1 is if P then Q, my premise 2 will be not Q, then the conclusion not P. Yeah. That's how it works. Okay. Another thing is every argument, okay, we can say whether it is sound or not sound, valid or not valid. Okay. So what makes it valid or not? Okay. Valid or not basically is the format. If it follows either Form 1, Form 2, or Form 3 format, it's correct. Yeah, it's valid. Sound is whether everything is true or not. So all the parts have to be true in order for the whole thing, for the argument to be sound. Any of it is false, it's not a sound argument. Yeah. Okay. So if I say, for example, humans have 3 hands. Yeah. So maybe Ali is a human. Then I say Ali has 3 hands. Doesn't make sense. So this is false. This is also false. Yeah. Okay, so it's not a sound argument. However, it's still a valid argument because, sorry, it should be all. Yeah. It's still a valid argument because the format is correct. I'm arguing in the correct way. It's just that the facts that I present is false. Okay. So here we just want to complete the arguments so that it's valid and sound. So we just fill in what makes sense. So you see, all factors of 4 are factors of 8. 2 is a factor of 4. So I'm talking about 2 here. That's the subject. So I need to talk about the same thing, 2. So it fulfills the first condition here, means it should fulfill the second condition for the conclusion. So 2 is a factor of 8. Yeah. Premise 2, if x equals to 5, then 2x plus 8 equals to 18. Then I have premise 2. Conclusion is 2x plus 8 equals to 18. So fulfills this condition means it should fulfill first condition, means x equals 5. Yeah. Subject here is x. It's still x. It doesn't change. So not necessarily they have to change that. This one, premise 2 is sine square a plus cos square, sine square alpha plus cos square beta is not equal to 1. Conclusion, alpha not equals to beta. Now, this is not and not, means it's using contrapositive. Yeah. Means not Q, then not P. In other words, the premise 1 will be if P means alpha equals to beta, then your Q. Sine square alpha plus cos square beta equals to 1. Okay, that's how it works. Part D, just fill in the conclusion here. So if P is divisible by 18, P is multiple of 18. 54 is divisible by 18, so I can say same subject, 54. So 54 is a multiple of 18. Yeah. Part E, negative 4m less than 0, then m more than 0. This one, negative 4m more equals 0 as the conclusion, means not P. So premise 2 should be not Q, the negation of m more than 0. M less or equals 0. Part F, all quadratic functions have turning point. Conclusion is function gx has turning point. So I'm talking about function gx. Have turning point is for the conclusion means quadratic function would be the premise 2. So the function gx is a quadratic function. Yeah. Okay, that is question 7 here. Okay. Then we look at question 8. Given that the surface area of a cone, pi r bracket r plus s, make a conclusion by deduction for the surface area of the 5 similar cones such that r is 7 cm and s is 13 cm. Okay. So conclusion by deduction, basically we just use the information that they give you. Usually it's a formula. This one. Yeah. To find what they request from you, which is basically surface area of 5 similar cones such that r is 7, s is 13. So the surface area of 5 similar cones with r equals 7 cm and s equals 13 cm is, use the formula. So this is the surface area of a cone. So they say 5 similar cones means 5 times. 5 times of the pi r times pi r bracket r plus s. R is the 7. 5 pi times 7 bracket 7 plus 13, which is, just calculate, 5 times pi times 7 times 20. 5 times 20, 100 times 7, 700. Usually I live in terms of pi. 700 pi cm square. Okay, the whole thing is the answer, not just the 700 pi. So try to write out a whole sentence. Okay, write out a whole sentence. You don't have to actually write out the formula, but I usually prefer to. Okay, you can straight away write is 700 pi cm square. Part B, given that the equation of a straight line is y equals mx plus c. Make a conclusion by deduction for the equation of the straight line PQ such that m equals to 3 and c equals to 5. Okay. So the equation of the straight line PQ is y equals, just put the m3, 3x plus c. C is 5, so plus 5. That's it. Okay. Yeah, that's by conclusion by deduction. So we also have conclusion by induction. So what's the difference between conclusion by deduction and conclusion by induction? Deduction is based on facts and statements that we already know. Okay. Induction is based on pattern. Okay, on pattern. So when we see 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. 4 times 2 is 8. All these are even numbers. So we can conclude like any number times 2 is an even number. Yeah, that would be one. Yeah, something that we can draw by a conclusion that we can draw by induction. We can also be something that's forming a formula of a sequence. That is also an expression of a sequence, actually. Yeah, that will also be conclusion by induction, by looking at how the pattern works. Everything plus 3, then x plus 3. Yeah, then it will be x plus 3, where x is 1, 2, 3, 4, and so on. So that is basically how it works. By looking at how the pattern is, we draw a conclusion. Okay. So in real life, conclusion by induction actually happens a lot, because there are a lot of things that we cannot determine with full certainty. For example, like in, say, medical. Okay, all of it is just based on statistics, but can we really draw a conclusion? We cannot, but we can. Sorry, can we really draw a conclusion from like facts and all? We cannot, but we do it by referring to the statistics of how the pattern of things work. Okay, so here basically what we want to do is determining the pattern, the expression of that forms a sequence. So the conclusion here will be the pattern of this sequence is, look at the number that changes here. That we put as n. So it's basically n squared minus 5, where n equals 1, 2, 3, and so on. Yeah. So for B, is this the power that changes? Okay. So the pattern will be 2 to the power n plus 3, where n equals, so n doesn't have to start from 1, it can also start from 0. In this case, it starts from 0. So 0, 1, 2, 3, and so on. Yeah. Okay. This one, this changes. This also changes. However, instead of 1, 2, 3, 4, this is 1, 4, 9, 16. Okay, you cannot have the number jumping like that. So we need to see what's the relation of it. Okay. If you straight away see the numbers 1, 4, 9, 16, by right, you should be able to recognize it. These are perfect square numbers. means it's the same as 1 square, 2 square, 3 square, and 4 square. In other words, it's 4n plus n square. Yeah, where n is 1, 2, 3, 4, and so on. Yeah. For part D, 1, 2, 3, 4 here, 0, 1, 2, 3 here. So it starts with a different number. So these two numbers can be related. So there are two ways of writing this. You can write, if you put 1, 2, 3, 4 as the n, then it's 3n plus 2 times. This is one number less than n, means it's n minus 1. So n minus 1 square. Yeah. Where n is 1, 2, 3, and so on. Or you can also put the 0, 1, 2, 3, 4, 0, 1, 2, 3 as n, means 3 something plus 2n square. This is one number more than n, means it's your n plus 1. So 3 bracket n plus 1 plus 2n square. Where n is, instead of start from 1, start from 0. 0, 1, 2, 3, and so on. Yeah. Okay. Either this or this. Either one is fine. Yeah. In the textbook answers, they only gave this first one, but this second one should be acceptable as well, because there's no specification whether you start from 1, start from 0. So both also can. Right? Then let's look at question 10. Determine whether the following arguments are inductive or deductive. So like I said just now, inductive is when it's based on pattern, deductive when it's based on facts or statements. So all the pupils from class 4 Bahagia perform on Teacher's Day. Jayanti is a pupil from class 4 Bahagia. Then Jayanti performs on Teacher's Day. So that is conclusion by deduction. So deductive argument for part A. For part B, sum of 1 and 13 even numbers, 3 and 5 even number, 5 and 7 even number, 7 and 9 even number. So it's based on how the pattern of this works. So it's by inductive. Inductive argument. Yeah. Okay, just like that. Question 11. Diagram below shows the number of cylinders of equal size arranged in the boxes according to number pattern 3, 5, 7, 9. Part A, construct a conclusion by induction for the pattern of the number of cylinders above. So 3, 5, 7, 9. Just look at how they relate. Plus 2, plus 2, plus 2. So it relates with plus 2. So actually creating the conclusion, we can use the, what do you call it? Numbers, patterns and arrangement, which you should have learned before in your lower forms. But if not, you can also relate them. Just basically it's plus 2. It's plus 2 how many times? So it's basically related using plus 2n. Starts off with 3, I can put a 3. Yeah, just that the n starts with 0. 1, 2, 3, and so on. Okay. If you don't want to put 3 plus 2n, you can put 1 plus 2n, where n is 1, 2, 3, 4 as well. Doesn't matter. It's the same thing. Okay, for part 8. For part B, radius and height 14 and 10 cm respectively. Calculate volume of cylinders in box 8. Total volume of cylinders means how many, means first I need to find number of cylinders. So if I use this, it'll be when n is 8. But if I use this one, then n is not 8. Sorry, it's also n equals. Okay. Yeah, it's not n equals to 8. Because the first one is a 0. Means it's 1, 2, 3, 4, 5 like that. So means box 8 is when n is 7. Okay, so you need to be aware of that. That's why in this kind of question, it's more suitable if I use this one. Okay, then I straight away put n equals to 8. So let's say I use this 1 plus 2 times 8, 17. There are 17 cylinders, means the total volume 17 times of the volume of a cylinder. So radius is 14 cm, means pi r square h, pi times 14 square times height 10. Okay, so I calculate. Feel free to use calculator again. 17 pi times 14 squared times 10. Okay. You never say what to do with the pi. If you use 22/7, that would be the answer in your textbook. However, they did not specify here what pi to use and all. So if you just use pi, it'll be fine. Yeah, it'll be fine as well. Okay, so 33320 pi cm cube. Yeah. Okay. Or if you follow the textbook answer, then just use the 22/7, 104,720 cm cube. It's fine. It's slightly different, but because they did not specify what to use, so it's fine. Okay, then question 12 here. Diagram on the right shows the first 4 semicircles arranged according to to a certain pattern. So the radius of the largest semicircle is 32 cm. Okay, so it keeps becoming smaller like that. Largest semicircle radius is 32 cm, means this one is 32. Each of this, it becomes half of it. Basically, here will be the middle to the circumference, means it's the radius. Radius is half. So it keeps becoming half of the radius. So calculate and list the parameters of the 4 semicircles in terms of pi. Okay, so they want the perimeter, not the area. So I find the first perimeter. So a full circle circumference would be 2 pi r, means this semicircle arc is half of that. So it's pi r. So first parameter is basically 32 plus 16 pi, half of the radius. Okay. Second parameter is 16 here plus half of it, 8 pi. Third parameter is, actually I can just list it out in a line. Yeah, but doesn't matter. Yeah, it's easier for you to see also. Half of it again, 8, then again half, 4 pi. Fourth parameter, 4 plus 2 pi. Yeah. Okay. So in the textbook, what they did is factorizing the numbers here. Oh, sorry, my mistake, my bad. It's radius that is given. That's the diameter. Means it starts at 64. So it's 64 plus 32 pi, and then 32 plus 16 pi, 16 plus 8 pi, 8 plus 4 pi. Should be like this. So like I say, the answers in the textbook is the factorized form. Means I factorize 32 bracket 2 plus pi. 5 plus 2, 2 plus pi, same thing. 16 bracket 2 plus pi, 8 bracket 2 plus pi, 4 bracket 2 plus pi. As you can see, it's the same, it's basically the same as the answers in the textbook. So part B, based on answer from part A, show that the generalization for the parameters of the 4 semicircles is this. So when we compare like this, in this form, basically I look at the 32, 16, 8, and 4. Yeah. So 32 is 2 to the power 5. Yeah. 16 is 2 to the power 4. 8 is 2 to the power 3. 4 is 2 to the power 2. Yeah. So you can see here, 5, 4, 3, 2. Yeah. Which is basically the same as 2 to the power 6 minus 1. 5 plus 2. 2 to the power 6 minus 2, 5 plus 2, 2 to the power 6 minus 3, 5 plus 2, 2 to the power 6 minus 4, bracket 5 plus 2. So you can see it's basically the same, 2 to the power 6 minus n, n is the 1, 2, 3, 4, times 5 plus 2. Yeah. So that's the part B. Part C, calculate the parameter in cm of the 8th semicircle. 8th semicircle means basically n is 8. Yeah. So parameter of circle 8 is 2 bracket, sorry, 2 to the power of 6 minus 8 bracket pi plus 2. Means 2 to the power of negative 2, 1 over 4. 1 over 4 bracket pi plus 2. You can leave it in this form. Yeah, that's the answer. So that's for question 12 here. Yeah, so that's for all the questions in chapter 3. So if you want to revise, you can always look at the concept map to see what are the things you need to know. Okay, which is basically everything that I've gone through just now. So actually one thing I didn't go through is the strong and cogent when it's inductive argument. So for deductive argument, just now I went through how is it valid, how is it sound. Inductive argument, okay, we can see whether it's strong or not, cogent or not. Okay, so strong or not strong, strong or weak, basically strong or weak is based on if everything is correct, if all the patterns, like for this one, these 4 are correct, assuming that they are correct. So whether or not they're correct, I assume they're correct. If they are, how likely is it likely for the conclusion to be true? Yeah, is it leading to the correct conclusion? If it is, then it's strong. If it's not, then it's weak. And if it's weak, definitely it's not cogent. Because a weak argument means your conclusion should not be correct. It will already lead to a wrong conclusion. So definitely it's not cogent. So weak, usually we don't need to determine whether it's cogent or not. If it's strong, we have to still determine whether it's cogent or not. Cogent or not is based on whether every parameter, every premise is true or false, including if every premise and also the conclusion is true. If it's true, then only it's cogent. If it's not, then it's not. Okay. So yeah, basically in this whole chapter, first thing, if it's a statement, we have to see whether it's true or false. Sometimes we have to negate the statement, or we can combine it, compound statements. If it's an implication, we may need to separate or combine them into separate into 2 implications or combine 2 into 1. Make sure you also know converse, inverse, contrapositive, how it works and how they are related. Then I have arguments. I have inductive and deductive arguments. Inductive argument, whether it's strong or not, cogent or not. Deductive argument, whether it's valid or not valid, sound or not sound. Yeah, and then of course, drawing conclusion based on the premises, filling up the premises for your deductive arguments, or filling out conclusion as well, of course. Yeah, make sure you remember these 3 forms of your deductive arguments as well, because that's important to determine whether it's valid or not. If it doesn't follow, then it's not valid. Okay, so yeah, basically that's the content for chapter 3. Yeah. So again, I'm Damian from Pusat Tuition 30. And again, we sell notes. If you're interested with the notes, interested in joining our class, or just interested to find out more about us, do follow us on our social media or contact us on any of these numbers to acquire more information. Yeah. So that's it for this video. I'll see you all in the next one. Thank you. Bye-bye.